Let's look at an example where we use one of our sum or difference formulas to find the exact value of a trig function, of some angle. So let's find the sine of 285 degrees. So again, we're wanting to use a sum or a difference formula to find the sine of 285 degrees. So I need to rewrite this as the sine of something plus something or something minus something. So I'm going to write this as a sum or a difference. And I'll go ahead and say in this case we're going to write it as a sum. But I want to fill it in with two angle values. I want to plug it in, fill it in with an angle value here and an angle value there. Now, I want to use angles that I know something about. So we know stuff about our 30-degree reference angles, our 45-degree reference angles, and our 60-degree reference angles. We know stuff about 30, 45, and 60. So we want to use angles that we know that have those as reference angles, that have 30 as its reference angle, or 45 as its reference angle, or 60 as its reference angle, and we want those two angles to add up to 285 degrees. Well, for example, if I use 60 and 225, that would be 285 degrees. And 60 has a 60-degree reference angle, and 225 has a reference angle of 45 degrees. So I could use 60 and 225. Are there others? Yes, there are others. It doesn't matter what two you use. And for example, you could use 150 and 135. 150 has a reference angle of 30 degrees, and 135 has a reference angle of 45 degrees. So it doesn't matter what two angles you use, they just have to be values for which they have nice reference angles, like a 30-degree reference angle, a 45-degree reference angle, and a 60-degree reference angle. So again, you pick one of them because you're going to get the same answer no matter which one you use. So I'm going to use 60 and 225. So I'm going to rewrite 60 degrees, 285, sorry, as 60 degrees plus 225 degrees. So there's my A, and there's my B. And so now I'm going to use my sum formula, which you don't have to memorize. I'll give you a formula sheet for your test, but you need to know how to use it, and this is one example where we're using it. So, formula says the sine of 285 is the sine of A, sine of 60, times the cosine of B, so the cosine of 225 degrees. If there's a plus in our formula, which there is, there's a plus here. So sine 60 cosine 225 plus, and then it switches to cosine of 60 degrees, sine of 225 degrees. So again, I'm just using my formula to expand that. And now I know all four of these values. I know what the sine of 60 is. I know what the cosine of 225 is. I know what the cosine of 60 is. I know what the sine of 225. I know all four of those values, or I can find them using my reference angles and the quadrants they're in and such. So sine of 60 degrees, that's the square root of 3 over 2. Cosine of 60 degrees is a half. Cosine of 225. So 225 has a reference angle of 45 degrees. So we know cosine of 45 is square root of 2 over 2. We want to use the rationalized form here. Now 225 is in the third quadrant, and in the third quadrant cosine is negative, so 225, cosine of 225 is negative. Same thing with the sine of 225. It's negative in 45-degree reference angle, so square root of 2 over 2. Again, watch your signs, your positive and your negatives when you're doing this, and you're looking at the angles you have down here. So I'm looking at 60 and 60 respectively. Those are in the first quadrant, so sine is 60 and cosine 60 are positive. And then I'm looking at 225 for cosine and sine. That's in the third quadrant. And I know that in the third quadrant, sine and cosine are both negative, which is why I use those values there. And now we're just going to simplify this as much as we can. So square root of 3 times the square root of 2. That's the square root of 6, and we have a positive times a negative, so it's going to be negative square root of 6 over 4. Plus, over here, you have 1 times negative square root of 2. That's going to be negative square root of 2. All that over 2 times 2, which is 4. And so my final answer, I have my common denominator of 4, and then it's negative of the square root of 6 plus negative square root of 2. Or if you prefer, you can write it as minus square root of 2. There's a couple different ways you could write your final answer, but that's perfectly fine. There's nothing wrong with writing it in that form there. So that's one example where you're given one angle value and you want to split it into two different angle values. Now, this angle here, so let me just talk about a couple of things. I won't work through another example, but let me just talk about a couple of things. This angle value right here may not be in degrees. It may be in radians. If it's in radians, probably the best thing I would tell you to do is convert it to degrees, because it's going to be much easier for you to find your sums and differences and such using degrees. So make sure that you put that angle in degrees if needed. That's probably the easiest way to go about it with these problems. And pay close attention to what function you're looking at here, in this case sine. So use your correct formula. In this case, I expanded it with the sine of a plus b. If that had been cosine, it would have been a different formula, so be careful about that as well. And then again, be careful down here when you're doing your trig values that you use the correct sign, whether it's positive or negative, respectively. And then just simplify your answer as much as possible. And we want an exact answer, so we're going to leave it in that form there. We're not going to figure out what that is in the decimal or anything. So these questions involve you having to go through and do that. You're not pulling out your calculator and just hitting sine 285. That's going to give you a decimal answer. We want the exact value, and the only way we can do that is going through the process that I went through here. One other thing I want to show you with the new example here, and that is you'll see some problems that will start off like this. It'll start off as cosine of 40 degrees, cosine of 80 degrees, minus, and then sine of 40 degrees times the sine of 80 degrees. And the directions will say something along the lines of find the exact value of this expression. So in this case, this one has already been expanded by my formula. I'm going to take it and I'm going to put it back together. So I have an A and a B respectively. So I have cosine A, cosine B, minus sine A, sine B. If you look at your formulas, you'll notice that the one that is cosine, cosine, minus sine, sine, that is the formula that says cosine of A plus B. Be real careful. Make sure you use your formulas. If it's minus with cosine, it turns into a plus when you put it back together, if you look at your formula there. So my A and my B respectively are 40 and 80. So it's asking me to find what's the cosine of 40 degrees plus 80 degrees, which is the cosine of 120 degrees. And that's a value that we know. So the point really was just kind of testing you and making sure you can recognize which formula that it is. And it was the cosine sum formula for cosine expanded. And so we put the formula back together into its formula before it was expanded, which is just cosine of A plus B. And then I plugged in my values for A and B respectively. So now we have the cosine of 120 degrees. So we're in the second quadrant. And we have a reference angle of 60 degrees. So second quadrant, we know cosine is negative in the second quadrant, and we have a reference angle of 60 degrees, and if you will use your triangle or use values you have memorized, whatever, cosine of 60 degrees is a half, so we're in the second quadrant, so cosine of 120 is going to be negative 1/2 for our final answer there. So those are just a couple of examples that hopefully will kind of help you and guide you through how to use the sum and difference formulas for sine and cosine respectively.